The wastewater treatment facility at the City of Lethbridge has a comprehensive lab on site which performs various tests on wastewater samples from different parts of our process. The results from these tests have historically been manually collected with pen and paper records and then entered by hand into Excel spreadsheets for analysis. The end goal is to provide meaningful metrics that the plant managers can use to control our treatment process as effectively as possible. To support all of the automation at the plant, we have two full-time programmers, myself and Chase. Here is us going into cartoon mode for the remainder of the slides. Anyhow, our treatment facility has been consistently running above 95% capacity for several years, and as such, any increases in process efficiency are extremely important to us. At this point, even 1% matters. Massive expansions of the plant are still a few years out, and we need to figure out how to survive in the interim. One of our tactics is to get more and better quality data from our lab so that every last bit of performance can be squeezed out of our system. This is where a laboratory information management system, or LIMS, coupled with automation where possible, can be helpful. We briefly looked at commercial LIMS systems on the market, but fairly quickly realized that they can be expensive. They're limited in their configuration capabilities, they're limited in their ability to interface to real-world devices, and they would still need to have their database integrated to our existing ICS data for maximum effect. We then realized that since we already own a Vtscada installation and have in-house programming expertise, we could effectively DIY a solution that would be cheaper and fit our specific needs more precisely than anything that's out there. So let's take a look at some of the systems we have built. This is our Mettler Toledo scale that we use to weigh sample papers at one of the lab workstations. It has an RS-232 port for serial string data to go to external equipment. This is an interface box that I built out of an Arduino and some 3D printed parts to interface to that serial port and then serve Modbus TCP registers to our Vtscada system. And finally, this is the TSS workstation page that Chase developed using his own widgets and script code. It has features such as out-of-range warnings. It auto-steps the technician through the proper workflow by advancing to the correct cell after each interface button press. It calculates things that used to be done in Excel. It has really nice hard copy reports. There are data override controls and much more. Here is the system in action. The lab tech loads a sample, waits for the reading to stabilize, and then presses the button on the interface. It then emits a couple of blinks on its LEDs to indicate proper communication with both the scale and Vtscada, and then the data reading is automatically filled in on the SCADA page. The system steps the technician to the next cell on the sheet and waits for a new sample to be loaded. The result of this upgrade is that we have removed a lot of tedious manual data entry and streamlined the workflow. Now let's look at the settleometer station. This workstation involves pouring samples from 5 different parts of the plant into graduated beakers, then stirring those samples, setting a 5-minute timer, and when it expires, the level of the settled sludge on each beaker would be visually read and manually recorded on a clipboard. The timer would be reset and the process continued for 30 minutes. The data was then entered into a spreadsheet later in the day. Phase 1 of this workstation upgrade involved Chase building a Vtscada page that works with a touchscreen and also incorporated an automatic on-screen timer with audible beeper. Now the operator can enter the data directly into the database at the time of measurement, eliminating the need to handle that data more than once and also reducing transcription errors. Also, the timestamp is much more accurate for each sample since it is recorded automatically by Vtscada at the moment the screen is touched for each cell entry. The upgrade again resulted in improved workflow, more accurate data, a more graphical interface with automatic trending, hard copy printouts, and automatic out-of-range warnings. All good things. Phase 2 of this workstation upgrade is currently in development and will incorporate a fully automatic settling measurement instrument that I am building in-house. The proof of concept prototype is working, and later this year I plan to build 5 refined copies of it for deployment in the lab. The Phase 1 touchscreen mode will remain in place as a backup method. We are applying these concepts to various other workstations and pieces of equipment in our lab, such as our sample drying oven, our sample storage fridge, our pH measurement workstation, and our spectrophotometer workstation. And of course, we will continue to build out our system as new opportunities arise. By integrating all these workstations and equipment into our Vtscada system that already serves our industrial control system, we have realized a number of benefits. First, all data sources from both systems are automatically integrated into the same database. Second, the full power of all Vtscada features, such as the historian, widgets, script code, security controls, and more, are available to the lab information management system developer. Another benefit is that the workflow between all of the lab workstations can be streamlined. If a certain sample is not to be done on a given day, that can be set in the first workstation, and all downstream tests at other workstations can be skipped automatically for that sample through careful screen design. Another benefit that's a little less obvious is that because the same technology is used for both the industrial control SCADA system and the lab information management system, in-house programming expertise gained on one system transfers seamlessly to the other side. I mostly do the ICS, Chase mostly does the LIMS, but we can cross back and forth as needed. Looking to the future, once the LIMS is built out, I plan to begin a new project using the same Vtscada application to begin building a network intrusion detection and monitoring system for our facility. Stay tuned for a presentation on that caper when it lands, and thank you for your time.